Today we're going to look at primary key design and how you can harness it to get the best performance out of CockroachDB. I'll start by creating a 3-node CockroachDB cluster, generating a bunch of data, about 1 million rows, creating a table called member that has an ID, email, full name, date of birth, and join date. The primary key of this table is the ID, and because it's not using any properties associated with a member, it's known as a surrogate key. I'll import those 1 million rows into the table. It's unique on email, so I'm not expecting the full 1 million. And then I'll turn off SQL Safe updates because of the kind of changes that I'll be making shortly. With that set up, I'll select a random email from the database. I'll now use that email address to perform a search. I'm not expecting great performance from this because there's no index on the email address at the moment. So about 340 milliseconds. If I do an explain on that, we'll see why. And we're having to do a full scan over the primary key index, simply because we have to scan the whole data set in order to find that one email address. CockroachDB is recommending that I create this index, which is a covering index based on the email address and storing the full name and date of birth. We'll create that index in a minute, but I just want to show you what it looks like if I don't. So I'll create an index on the email column, but I won't use a covering index. I won't store any columns within there. If I run the same query using the email address as a filter again, this time we're seeing latencies of around 3 milliseconds. So that index has definitely fixed the performance for us, but we can do better. If I do an explain on this, we'll see that while we've got rid of the full table scan, we're having to do what's known as a primary key lookup in order to get the data that we're asking for, simply because the email index doesn't provide that information within itself. With this query, I can see how much that email index is actually consuming in CockroachDB. And it's around 68 megabytes and covers the entire table set. I'll drop that index now and replace it with the covering index that CockroachDB was recommending in the first place. If I run the same select again, what's interesting to see now is we're no longer joining back to the primary key in order to get the data out the table. We have it immediately available to us from the index itself. If I look at the size of the index now, it's risen to 87 megabytes, which isn't much more than it was before, but that's because it's storing the data that we need for that query. If I ask for a column that's not part of that covering index, the query latency is still really good, but if I do an explain, we'll see that CockroachDB is now recommending that we add the new column into the covering index, and we're doing the join back to the primary key once more. Surrogate keys, especially when they're using the data type of UUID, offer a great source of randomness that helps your data get evenly distributed across the cluster. However, if your queries don't make use of the surrogate key, if they don't ask for data by the primary key directly, a surrogate key might not be the best choice. In this example, I was only using the email for filtering. So why not make the email the primary key? Let's see what that looks like now and the flexibility that gives us when it comes to selecting different columns from the table. I'll drop the email index. I'll update the primary key to be the email column instead of the ID column. This is an online schema change or a zero downtime schema change, so users of this table wouldn't notice any impact from the queries that I'm running now. If I show you what the table looks like now, the primary key is now the email, and we have a unique constraint on the ID. I'll delete the ID column now because we simply don't need it. And if I show you the create statement again, now all we're left with is the email, full name, date of birth, join date, and the primary key is the email address. I can continue to filter on the email, which is now the primary key, and we're doing direct lookups against the primary key this time. There's no primary key index join because the email address already contains all of the columns that we need. And because the primary index essentially covers all of the columns in the table, it doesn't matter which columns we request from the table, they're always going to be part of that index. The use of the email column as the primary key in this example is known as a natural primary key. Let's see what using multiple column natural keys looks like and the kind of considerations you would want to make to achieve the best performance. I'll add a column to the table called market and set random values for Spain, Germany, France, the US, and the UK for each of them. With the data in place, I can now make that column non-nullable and then update the primary key to use both the new market column and the existing email address. Let's look at what the underlying ranges now look like. And what we can see is the primary key for this column is now the composite value of the market and the email address. Notice that because the primary key is ordered sequentially, we've got a big block of DE for German market users, then we'll have a big block of FR for French users. This might result in hotspots because the data won't be uniformly randomly distributed across the cluster. So the order of these composite natural primary keys is something to be aware of. Let's switch the order of those columns and see what that looks like. Again, this won't require any downtime to the application. With that change made, let's have a look at the ranges again. And this time, the primary key is ordered by email and then market, which might offer better random distribution across your cluster. To summarize, the UUID type in CockroachDB offers really good uniform randomness, which is great for ensuring random distribution of data across the nodes in your cluster. They're not always the best choice, however, as I've demonstrated with the email address example. If you're always filtering based on a column like email address and never really using the ID for filtering, that will necessitate the use of either covering indexes or primary key lookups back to the table to return the data you're requesting. Consider creating natural primary keys or composite natural primary keys if the shape of your data lends itself well to that. You might still be able to achieve the uniform distribution of data across the nodes in your cluster, and you might also gain efficiencies because you won't be doing the primary key lookup and the data is inherently stored against that primary key for you.